All right, here's the second part to our lesson with composite inverse trig statements. The first half of the lesson, all of these values in here were on our unit circle. So today's part of the lesson is how do you find the values when they are not on the unit circle? And this is a skill that we did in the last unit as well. And you're going to use triangle math, your SOHCAHTOA, sine, cosine, tangent ratios to figure these out. So I want you to take a minute and just write in these ratios just so we can have them as a reminder. Sine is y over r, cosine is x over r, tan is y over x, cosecant is 1 over sine, which means take the reciprocal of the sine ratio. So instead of y over r, it's r over y. Secant is the reciprocal of cosine, so it'll be r over x. And cotangent is the reciprocal of tan, so it'll be x over y. And we are still going to begin by working from the inside out. So we're going to start in the parentheses here and then do the outside function second. So today we're going to think about this a little bit differently. So we still have an inverse function in here, and this is asking us what angle has a tangent value of 5 over 12. That's what this is asking. Now, we don't necessarily need to figure out what that angle is. I'm going to write this a different way. This is asking me the tangent of what is equal to 5 over 12. And I'm not really going to solve for that x. What I need to know is that this is my tangent value. This is my y over x values. So from this ratio, I know that y equals 5 and x equals 12. All right, so that's all that I need to know from here. I don't actually have to know what the angle is because whatever it is, let's call it theta, I'm about to take the sine of that theta, which means I still need my y value. I can use the same y value. And for the ratio, I would need the r. And I don't have to actually know what this angle is to figure out that r. I can just use my triangle properties. So if I have a right triangle where y is 5 and x is 12, the hypotenuse is my r value. So I just use the Pythagorean theorem. The sum of the square of the sides equals the square of the hypotenuse. So I've got 5 squared plus 12 squared equals r squared. That's 25 plus 144 equal to r squared. That's 169. And then you're going to square root, and r is 3. So I know y is 5, x is 12, r is 13. And now to find the sine of whatever this theta angle is, I'm going to use this ratio. Sine is equal to y over r. So y was 5 and r is 13. And I'm going to do number 2 next right here. So inside the parentheses, I have that inverse cotangent of 3. Cotangent is x over y. So now that is a ratio of two things, x over y. But all I have in the parentheses is one value. Now there's an implied denominator of 1. So that makes my x value 3 and my y value 1. And now that I have that, whatever angle this is, I'm going to take the cosecant of it. So cosecant is r over y. Well, I have x and y, so I need to use Pythagorean theorem to solve for r. So I just do this again. X squared plus y squared equals r squared. So that will be 3 squared plus 1 squared equals r squared. That is 9 plus 1 equals to r squared. 10 equals r squared. Square rooting both sides gives me the square root of 10 for r. Now taking the cosecant ratio, cosecant is r over y. We just solved for r is rad 10. Remember, r Also, we talked about in the last unit, R is always positive. So rad 10 over 1 or just rad 10. And I want you to take a minute and pause the video and try number 4 by yourself. Okay, so now hopefully you paused and tried that by yourself. One different thing about this value in here is that it's negative. So let's look at so we have to figure out, well, which is negative, the top value or the bottom, because that will be important when we go do this ratio, maybe, in a minute. So the ratio for sine is y over r, and this actually right here gives me the information that I need, because r is always positive, so that means the y value is the negative. So y is negative 8 and r is positive 17. So to figure out cosine, I need the x value. So I don't have that yet, but I have y and r. So using Pythagorean theorem, I have x squared plus y squared, y is negative 8, equals r squared. So that's x squared plus 64 equals 289. Subtract 64 to both sides gives me x squared equals 225. And square rooting both of those gives me x is 15. So cosine is x over r, or 15 over 17. Okay, and now you pause the video again and try number 3. All right, so on 3 we have 5 over 1, and the cosecant ratio is r over y. So that gives me my r value and my y value. I need to solve for x. So x squared plus 1 squared equals 5 squared. X squared plus 1 equals 25. X squared equals 24. Square root both sides, x equals square root of 24. And then the tangent ratio is y over x. I know that y is 1, that x is rad 24. So 1 over rad 24. I'm going to rationalize the denominator here. So that equals rad 24 over 24. Now, if you have a free response question on your quiz or test, I'll take this answer. But if this makes you twitchy and you feel like you can't rest until this radical is simplified, then that's going to look like this. So rad 24 is the square root of 4 times 6. That square root of 4 simplifies to 2. So this is 2 rad 6 over 24. 2 over 24 simplifies to 1 over 12. So I would take this answer as well. This is not wrong, but it's also not simplified. So the simplified answer is in this form. And then the practice problems for this type are just the second half of the practice sheet that we already started last week.